Hey everybody, this is Larry. This is me trying to do a bonus problem that I haven't done before. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one on February 20th, 2024. I almost forgot the year for a second. Alright, we have a hard problem today, so hopefully not too hard. Hopefully it's still solvable. 805 split array with the same average. You are given an integer array nums. You should move each element nums into one of the two arrays, A and B, such that A and B are non-empty and average of A is equal to average of B. Return true if it's possible to achieve that and false otherwise. No depth for an array. Okay. So basically this, that's an interesting one. So the first thing is noticing that the order doesn't matter. So yeah. Yeah, so basically, okay. The thing to notice is that n is dirty. So what does that mean? That means that we can do some funky algorithms. Obviously, 2 to the 30 is going to be too slow. So what can we do, right? I mean, to be honest, 2 to the 30 immediately jumps to me as split in the middle or meet in the middle. But that's kind of like I don't know. And this is just a little bit meta. It's just that it's a very hard thing to expect people to know. So on an interview, that would be ridiculous. Let me give it a little bit of a thought to kind of think about. Kind of hard to say. I mean, the other way that I would think about it is that because nums of I is 10 to the 4th, the other possibility is dynamic programming, right? That may be probably the easier way to think about it. I mean, the other way to meet in the middle, if we have to, maybe we can do it. But yeah, I think that should be fine. Yeah. This is kind of still tricky with dynamic programming. I mean, it's actually not that bad. I think I could do it with dynamic programming. It's just tricky for me to explain it. I'm trying to figure out a way, the clean way to explain it. But I think it should be okay, to be honest. Right. So, all right. I mean, I think we could just do brute force, or not brute force, but memorization, but with the idea of brute force. So right, so then now we can do something like and for this one, because it is a hard, I don't know how many people will watch as a beginner. Let me know in the comments, because I kind of struggle sometimes about like how much to or like the level to explain these problems. And so for today, given that this is a dynamic problem, I'm not going to do the dynamic I'm not going to explain memorization, or rather, I'm not going to explain basic memorization. I do that a lot of my daily videos already, at least in the past. So this time today, I'm just going to be a little bit lazy and not focus on that, because that's not the interesting part about this problem, I think. But yeah, but maybe I will. I don't know. We'll see how that goes. But basically, if you want to write brute force, you might have something like possible, I don't know, the index of the number, like basically how many are used, the current total, and then the number of items that are used in the total, right? Used to say. And in that case, let's kind of think about this for a second, right? Index could be 30, obviously. Total can be, like we said, 30 times 10, was it 10,000? Well, this is just 10,000, sorry, 10 to the 4th. And use is also up to 30. So then that means that this can go up to 9 million. Oh, wait, this, I'm really wrong. Total is way more than that, right? Total is the sum of 30 numbers, so it's actually, that's why I said it that way, but then I got confused myself. Is that, yeah, so it's this, right? So not all of them is possible. So in theory, in actuality, is that, now all of them are kind of possible, because you have 30 numbers, then you can just have you know, you get just all the powers of 2's, then that would be the summation of 1 to plus 2 plus 3, or 1, 2, 4 to 300,000, and then 300,000 times like 10, 20. Because then it'll be doubling until well, until 200,000. What is that? That is basically 20 doublings. No, it's like 16 doublings. So then it's 16 times 300,000, or 17 times 300,000 because of the doubling. So then it is a lot, right? But anyway, but yeah, so this actually comes up to be a lot. So this would actually not be a reasonable way to do this, right? Because now, yeah. Do I have to really do meet in the middle for this one? Maybe I do. I kind of missed because in my head I missed timesing this by 30. I think when I first initial, and then I also missed the used part a little bit, but because I was thinking about it up bottoms up, but maybe we have to do meet in the middle, right? How would meet in the middle work? It's not an easy meet in the middle either. You can also double check. 2 to the 15. What's 2 to the 15 again? Like 32,000. I guess that should be okay. I mean, no, meet in the middle would work if I could figure out how it works exactly with averages. Is there any other way of doing it? Is there another DP that's not knapsack? That was my first intuition, but well, okay. Maybe I have to play around a little bit with what the average means a little bit, because I think I have some in my head, right? So basically, average is just equal to sum of A over count of A, obviously, right? And then you have sum of B is over count of B. So then basically you have sum of A times count of B is equal to sum of B times count of A, right? And then basically we can convert this to n minus count of A, right? Something like that. Does that help us? So this thing should be equal to the other thing. And of course sum of B is just equal to total sum minus sum of A. Does that help? Don't know. Let's multiply that out, right? So sum of A times n minus sum of A times count of A is equal to some total sum minus sum of A times count of A. I think the sum of A times count of, am I doing this right? Oh, this actually times count of A on this side, whoops. But in any case, I think this part kind of cancels out, right? So, okay, let me just write on the next line so I don't know. I'm really bad at doing this on here. I'm usually better at paper, so maybe I'm just confusing this, but okay. All right. So then we have this. I mean, now it is kind of clear what that means, right? Oh, I mean, this is a property that, to be honest, I did not realize when I started writing this. So it just means that the average is equal to, well, the average of the entire thing, which is a property that I did not think about. Because basically it's just saying that the average of A is equal to the average of B, then there's average of the entire thing. So that means that now we have an idea of what we want the target to be, right? So then now it becomes a different thing, right? Because then now we have sum is equal, or let's just say total equals sums of nums. Then now what does that mean? That means that we can try, we could prove there's only 30 numbers, right? So we can try, if this is 1, then we know what sum A needs to be. If this is 2, we know what sum A needs to be, so forth, right? Because then now, so then we can prove, we can like basically we can say, is there one number with the average total over n? Is there two numbers with the, and then so forth, right? And here you can rewrite this as one number with this as the sum, right? This, and two numbers is this times 2 as the sum, right? That sums with. So then now we don't have to deal with the average anymore. Well, I mean, one number obviously is just 1, but you get the idea. Okay. This is actually a fun problem. And, I did not know how to solve this before. I mean, I had some ideas in my head, obviously, some impressions, but I didn't think about doing it this way. So this is a fun evolution for sure. Kind of an interesting problem. Okay. Right. And that's pretty much it then, right? Because then now this becomes a very straightforward whatchamacallit. Sorry, I got stuck in my head. A straightforward knapsack thing, right? That we kind of had before, with fewer states. Well, one is pretty straightforward. I'm trying to convince myself that I'm trying to make sure that what I'm saying is true. I think that's what I'm doing now. So 30 choose 2. I mean, this is 30 choose 2 is pretty straightforward. 30 choose 3 is pretty straightforward. What's 30 choose 15 again? I guess that's a big one. 30 choose. I guess I need Google for this. 30 choose 15 is. Even 30 choose 15 is only 155 million, which actually is a little bit slow, so we won't do it that way. But in theory, it's almost close enough to do. And also, with this way, the meat in the middle is actually pretty straightforward as well. I mean, the knapsack, I can see. But so, okay. So the other thing I want to point out is that it stops at, is there n over 2 numbers sums to average total times n over 2. Because then after this, if one number sums to average over n, it also implies that n minus 1 other numbers sums to ... right? So we only have to loop this to n over 2, which is to say that now, if we look at our earlier thing, we only have to go to 15. So we only have to sum to 15 numbers, right? So then now, basically, if we had our thing earlier of possible index, total, count, or something like this, I forget, or used. Now we reduced it to index is equal to, well, still up to 30. Total, you only sum 15 numbers, so then now it's, instead of, so it's this times 15 instead of times 30, and then used only goes up to 15. So then now what is this fast enough? Times 15 times 15 times 10,000. So that is 67 million. So still a little bit too much, even though a lot of them are not as possible. And because we go up to 150,000, a lot of them are not should not be possible. So it could, I think it probably is more borderline, even though it's possible. Was it 60? What did I say? 67 million or something. So this is 67 million states, but lazy math, right? Because technically speaking, it's going to be like the summation of all these things. So it's actually a little bit less. So it's or a lot less really, because it only goes up to 15. If you choose a power of 2 thing, then it kind of saturates pretty quickly. Or pretty like the first 10 doesn't do anything really. I don't know. I mean, I think maybe we can YOLO and go for this, but let's think about divide it in the middle, right? So divide in the middle, we have 2 to the 15 possible things, and then we can binary search. So that should be like probably the way we want to do it. 2 to the 15 is 32,000, and then log base is like times 15, maybe, and that should be good. So I think that's the way we'll do it. But yeah, really annoying problem. Not something that you would do in an interview. I mean, it's taking me about 16 minutes to kind of come to this conclusion. But this is a very fun observation to make, to be honest. And so, so I don't know. It's kind of fun. I like it. I dig it. But yeah, let's do the. So if you want to go, I'm not going to talk about this too much. I'm just. It's more of a. It doesn't. It's not that interesting of an algorithm. It's so limited in use, but it comes up randomly like here. But I don't even advocate learning it just because it just like when is it ever going to come up? Not much to explain. It's just doing it in a way such that basically instead of doing 2 to the 30 power, you do 2 to the 15, make 2 sets of answers, and then binary search on them so that you can kind of find the other thing, right? So yeah, yeah, maybe this time's like another 15 or something because like we want to brute force the number of things. So this is it's not that bad. Okay, yeah, okay. So here maybe we have a brute thing, right? List. So let's say an array. Let's just say m is equal to length of array, and then it is just, and I'm going to use a bit mask here, so please stay with me. Um, yeah, maybe not. Yeah, I'm just going to use a bit mask here, so please stay with me at home. Um, Sorry, I got to click on this. I don't know if people have watched my other video from like yesterday or something, for example. But apparently I have like possibly high blood sugar. Not like diabetic level, but still like I get things about it, so I have to like make sure it's still plugged in and all these things. Being old. Anyway, all right. So I'm going to use Bitmask. I'm not going to explain it in this video. There's already enough complication in this problem. If you don't know it, you should not work on this problem. And I hope that doesn't come off as mean. I just mean like you should work on other problems that kind of have all these basic stuff because this is not that problem for you. But if you want to watch me, then I'll just um, so basically, right, then okay, this is a different photo than that photo. So I don't know. But f of we add one set, and then total we add array set, right? And then append with f of count dot append. I think that's roughly 10, right? So we can, and basically, yeah, now we brute force it for half the way. Well, I guess this is the brute force way, but of course, if you put in the entire array, it's going to be 2 to the 30, and that's just too, not cutting it. Then what you want to do is, let's say left is equal to n over 2, and then right is equal to n minus left, and then now you want left f is equal to 2 force on what's it, nums to the left. I guess I don't really need to like the right side. And then the right, does that include the left? Maybe, I don't know actually. No, it doesn't. I mean this stuff here, right? And then here we'll just print it out for you to kind of for visualization purposes before I finish it. Just sorry about that happen. Yeah, basically now it takes it in half, 1, 2, 3, 4, and then it just brute-force all the possible, and this is the dictionary of the counts, and then the sum within those counts. And they're not, I don't think they are in sorted order though. I mean, in this case it is, just because it's a little bit lucky, but it's actually not usually. So actually, let me kind of go by that, which is for I in range of m, n plus 1, I suppose, because it counts can be n. Okay. F sub I, we want to sort it, right? Just doing a little bit sort. Just wanting to expect just to see that just like in an error or something. Okay, right. So then now we have this thing, and basically what the idea here is okay. So for I don't know, for I in range of left plus 1, so it's left inclusive, right? So it's left has left items, okay, right? So then now we look at this thing, right? Yeah, okay, maybe we can just do something like this actually, right? So yeah, and then now basically I plus j has to be greater than 0, because otherwise you just have 0, and then they're both empty, right? Yeah, so yeah. I guess they could be, no. If they can't both be empty. Basically, you're just combining possibilities, right? Basically, you're taking I from the left and j from the right side, because that's what it's saying. So, yeah, and then we'll just go through the LF of I, right? So for value in LF of I, let's just say left value. Then now, what is the target go, right? So target go here, so we have n over total, or sorry, total over n is what we are trying to reach. Is equal to some number, some x over I plus j, because that's the number we've taken, right? So we times stuff, so we have times I plus j, times n on the other side, right? And basically now, oh, I guess we don't times n on the other side, because we're looking for x, right? So x is the sum that we're looking for, and it's just like this number, right? So yeah, so we have to do a couple of things. Basically, check that this is a whole number. So if total times I plus j mod n is equal to 0, so this is now a whole number, which means that it's possible. Then I guess yeah. Then now x is equal to this thing, right? So that's the number we're searching for. So then now for left values, then now we're going to search from R of f of j. We're going to bisect left, we're going to search for x minus LV, right? So this is index. So if this is inside the length of RF of J and RF of J of index plus, I guess if this is equal to X, no, I guess it's this plus LV. If we go to X, just to verify it, then we can return true. Because that means that we found a number, and otherwise we return true. So that's pretty much it if it's correct. It may not be correct. Oh, I forgot X is not a real thing. Okay. So that was just like pseudocode that I didn't pick it up. Oh no. Why did I return true? So the average is gonna be 2. Yeah, let's do this one over. IJ OFI RFJ LE RFJ index. So maybe that I just have some typo thing. That doesn't seem to make sense. Okay. So we have one of each. Okay, that makes sense. 3 and 1, I mean that's the only possible thing. 3 and 1, also possible thing. What is X? X is 4. Why is X 4? Oh, okay. So the same way that this cannot be 0, it cannot be everything. I think that's basically the end. And I plus J is not equal to M. Whoops. I guess I didn't think it through. Alright, I didn't think that through. Okay, so then now we can check this out. The statement, and we'll just give us some. Yeah. Not a super fast solution, but pretty okay solution. Yeah, this is meat in the middle, everybody. Ridiculous farm, but actually, to be honest, I enjoyed it. Is there easy DP? Okay. Yeah, I don't. I wonder if, like in the past, the bounds are tighter or like less tight. Sorry, because I don't know. Because I don't know how these things would work. Yeah, I don't think because of, I mean, we did the analysis. I mean, and like maybe I thought it maybe could be tight, but yeah, this is basically what we're saying. And then now, this is actually ridiculous. I don't know what this is. Well, I mean, I kind of do, but it's just like I don't know. This is yeah, this is a little weird. But I mean, this part is the part that we did figure out, right? But yeah, I don't know. That maybe or it's just like bad. Hmm, I don't know how this works. This is it's just like massive. Oh, I see what they do. I mean, this is basically the same way that we have it, I think. Except I don't know. I think they do is kind of funky. Well, I mean, no. The way that they do is more. No, I mean, no. I think this is the way that is similar. They don't really explain this, but I think this is the way that we did it. Except for they do it much in a different. Uh, Apparently there are new cases. That's what. Maybe I don't know. Yeah, that probably new actually. Mm, yeah, I don't think these are right. I don't know what the intended solution is, to be honest. It seems like a lot of people did DP with bitmask. One person did it meet in the middle, and that's how we did it. Um, But that mean in the middle require all this stuff about like what we did, which is kind of cool. Is there a hint? Oh, no hint. But sometimes the hint like gives you what how they think it should be done. But I don't know. I'm just curious. So, yeah, no, finding this part is the trick. The key part about it. Hmm. Maybe that's how people did it. I don't think that's how. I mean, we did it a little bit differently, but maybe there's a DP solution as a result. Um, all right, friends. That's all I have for this one. I actually like this farm. It's kind of fun, but I also think it's not a good interview farm. It's a terrible interview farm. No one's gonna get this. At least with these bells, just because you know, I don't think beat in the middle is an algorithm anyone should learn. I mean, it comes up like once a decade or something, and it's kind of cute, but like it's trash. But yeah, yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, take good mental health. Have a great rest of the week, everybody. I'll see you later. Take care. Bye bye.